All right, guys, this morning we're going to be continuing our discussion about inequalities, talking about multi-step inequalities. This is 3.4, chapter 3, section 4. So I want to go through about 4 examples here. We're going to be talking about a couple of different subjects as we go through this. But let's look at this first one. Again, inequalities solve exactly like equations. The only difference is if you multiply or divide by a negative, then you're going to reverse the inequality sign. But other than that, everything else is the same. Okay, so first thing I'm going to do is go ahead and draw the line down through so that we know we're dealing with 2 different sides. And again, we could really attack this problem in 4 different ways. We could try to move this 1 to the other side. We could try to move the 6n to the other side. We could try to move the 3n or the 8 to the other side. It doesn't really matter which way you go. I will say this, in some of these questions, you're going to be asked to graph. And so I would highly encourage you to try to keep the variable on the left just for inequalities, especially when you're graphing, because then you can use the sign to tell you which way to go. So I'm going to try to probably do this that way, just so that you can kind of get the idea of how to get the variable on the left side. So I want to get the n over here on this side, which means I need to get this particular one over here on the left-hand side. So right now there's nothing here, so I have to assume that's a positive. I'm going to go ahead and subtract 3n from both sides. It's going to be my first step. And that's going to give me 3n minus 1. And I'm going to just carry this sign down with me, greater than. And here this is going to cancel out. And I'm just going to bring my 8 down. So that's pretty simple. We've got that pretty well completed. Now I need to isolate this 3n by itself on one side. So this goes right back to 2-step inequalities that we had before. So I'm going to add the 1 first. I'm going to do the addition or subtraction first, then worry about the multiplication or division. So there I'm going to add 1 to both sides. Of course, again, this is going to cancel. Negative 1 plus 1 is going to go away. So I'm going to end up with 3n greater than 8 plus 1 equals 9. And so the last step here, I'm going to divide by 3 on both sides, which is going to give me n is greater than 3. Okay, I've got to put that answer over here so you can see that as well. So again, that's basically the answer to that equation. That means any number that is greater than 3 would be an answer to this inequality, this question that we have. Okay, so this one kind of steps it up just a little bit because it's having you to do the distributive property as well. That's not something that should scare us. By this point, we should be pretty well acclimated to that. So again, that's going to be the first thing I'm going to do is look at my parentheses. I don't have any like terms in here that I could do. I don't have any exponents. So my next thing I need to do is multiplication. So I'm going to go ahead and multiply this 3 through every term. So 3 times t equals 3t. 3 times 1 is 3. And then minus 4t I'm just going to bring down. And I still have the greater than or equal to negative 5. So at this point, I just need to collect some like terms. Remember, when you distribute, a lot of times you're going to have to collect like terms after you get done. So it's not really time to move anything yet. A lot of students, they want to just start moving stuff immediately. But always look to see if you've got any like terms that you can go ahead and combine. So if we look at this, we have 3t and negative 4t. Now remember that negative goes with that particular term. So if I've got 3t minus 4t, that means I'm going to end up with a negative t, so make sure you note that, plus 3 greater than or equal to negative 5, okay? So at this point, I'm going to go ahead and do exactly what I did up here before on the other problem. I'm going to do the addition or subtraction first. In this case, I need to subtract 3 because I have a positive 3 right here. And notice I've got to keep this term, I've got to keep it the way it is. I can't just magically get rid of that negative right at this point. So I've got negative t is greater than or equal to negative 5 minus 3. If I'm at negative 5 on the number line and I go 3 more in the negative direction, I'm now at negative 8, okay? Now here's the key. Now I've got to do division because I've got to get t by itself. And even though I can't see it, there is a negative 1 right there, okay? So I need to divide out that negative 1 from both sides. And I'm going to move my work right over here just because I didn't leave myself enough room. So once I do that, these are going to cancel out, and I'm going to be left with t. But now notice what I did. I divided by a negative. Now, what is our rule of inequalities? If we multiply or divide by a negative value, then we have to reverse our inequality sign. So instead of greater than or equal to, I'm going to have less than or equal to, and then I can finish the work right here. I've got a negative divided by a negative. That's going to be positive. And then I've got 8 divided by 1, which is 8. So t is less than or equal to 8 would be my final answer for that particular question. Okay, so now let's move on to number 3 and 4. Number 3 and 4 are kind of special cases. And so we'll kind of discover that as we go through. And this is something that you're going to encounter as well on this particular practice. So number 3, we've got 10 minus 8a. We can't really do anything over here because those are not like terms, so we just kind of have to leave them the way we are. We do notice on this right-hand side that I've got some multiplication that's going on here. So I can go ahead and distribute this 2 through to both of these terms. So let's go ahead and try to work some of that out. 10 minus 8a is greater than or equal to 2 times 5 is 10, and 2 times negative 4a. So a positive times a negative is going to be negative. I can go ahead and fill that in. And then 2 times 4 is 8, and then the a just kind of comes along for the ride. So I want you to take a look at what we have left here. We've got 10 minus 8a is greater than or equal to 10 minus 8a. We could try to move some stuff around here, but what I want you to notice is this is exactly the same as this. So my question to you is could this ever be greater than or equal to this? Well, we already know just by looking that it is already equal to, because this is exactly the same as that. So in other words, it doesn't matter what number I put in here. For example, let's just put in a 1 for a. For example, let's say a was 1. Then let's go ahead and put this in here. I'd have 10 minus 8 times 1 greater than 10 minus 8 times 1. Well, if I do that math, I'm going to end up with 10 minus 8 times 1 is 8. So 10 minus 8 is 2, is greater than or equal to 10 minus 8, again, is 2. Well, can 2 be equal to 2? Well, sure it can. So that means any value I put in for a is going to be a solution, or it's going to work, okay? So anytime you get exactly the same thing on both sides of this, and there has to be this equal to part right here, if you have that situation, then you know that those two things, the answer to this is really, I'm going to give you 2 different answers. It could either be called infinite or all real numbers. And that's probably what you'll see more than anything. That means I could literally take any real number and put it in for a, and I should be able to get an answer to this solution that is correct. All right, so let's look at number 4, because on number 4, we have 6m minus 5. Again, nothing really we could do there, so let's just write that down again. And then over here, we have 7m plus 7 minus m. So again, looking for like terms, I see a 7m here. I see a negative m here. Now, what is in front of that negative, or what is in front of that m just after the negative? Well, we know that there's understood to be a 1 there, because there is exactly negative 1m there. So if I take 7m minus 1m, I'm going to end up with 6m plus 7. Now, this looks very similar to this up here, except that I have a different constant here, okay? So if I were trying to get the variable to one side, which is what we're used to doing, again, we said we'd try to get our variable on the left side just because we could use that to graph it. So if I take negative 6m from this side, then I have to also take negative 6m from this side. And notice what happens. This cancels out and this cancels out. So all I'm left with is negative 5 is greater than 7. Now, I want you to think about that for just a minute. Negative 5 is greater than 7. Is that a true statement? Well, of course, we know that negative 5 is not greater than 7. It's actually less than 7. So that means this statement is not true. In other words, because this is not true, then that means that there is no solution. In other words, there is no value that I could put into my original problem that would ever make this true, because negative 5 is not greater than 7. So no matter what number I put in here, it's never, ever, ever going to work. And just to prove that out for just a second, I'll show you here. So we had 6m minus 5, 6m minus 5 is greater than 6m plus 7. Let's just do the same thing we did a few minutes ago. Let's say that m in this example is 1 because it has to equal it for any number that we put in. So if I put in a 1 right here, I'm going to get 6 times 1. Well, 6 times 1 is 6. So I'm going to end up with 6 minus 5 is greater than, again, 6 times 1 would be 6 plus 7. Now let's just look at this. 6 minus 1, or 5 is 1. Sorry, I gave you the answer. Is greater than 6 plus 7, which is 13. Well, is this a true statement? Well, of course not. 1 is not greater than 13. So again, our answer here is no solution. There's no numerical value that we could put in for that variable that would make the statement true. So if you get a situation like this, where everything's the same except that the statement just does not come out to be true, if it does not come out to be true, then it is, in fact, no solution. So hopefully this has been helpful. And if you have any questions or concerns, you can obviously get with us and we'll do our best to try to help you.